Welcome to Spring LIB.
We want to find closed formula for the recurrence relations that we're given. So the first one starts at 5, and then the next term is the previous one with the minus in front. So it is easy because a1 is minus a0, a2 is minus a1, which is minus minus a0, a3 is minus a2, which is minus 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 a0. And so we see immediately that the closed formula here is given by a number of minuses equal to the index, so minus 1 to the power of n, that multiplies a0, which in our case is 5. Then we're given the sequence starting at 1 and satisfying a term is equal to the previous one plus 3. So a1 is a0 plus 3, a2 is a1 plus 3, which is a0 plus 3 plus 3, a3 is a3 plus 3 plus 3 plus 3, and you see they were summing as many 3's as the current index. So an is given by a0, which is 1, plus 3n, because there are as many 3's and as n. Now we have the sequence starting at 4, where every term is the previous one minus n. So a1 is a0 minus 1, a2 is a1 minus 2, which is a0 minus 1 minus 2. And so you see that every time we have a0 minus 1 minus 2 all the way up to minus n. So the closed formula will be given by a0 minus the sum of all the positive integers starting from 1 all the way to n. But there is a closed formula for this, so a0 is 4, and then we have minus, and that sum can be written as n that multiplies n plus 1 divided by 2. Now we have the sequence starting at minus 1, where every term is twice the previous one, minus 3. So a1 is twice a0 minus 3, a2 is twice a1 minus 3, which is 4 times a0 minus 6 minus 3, where the minus 6 of course is twice the minus 3 of a1. Then we repeat for a3. This turns out to be 8 times a0 minus 12 minus 6 minus 3. Let's do one more. So a4 is twice a3 minus 3, and again we have 16 a0, and then we have minus 24 minus 6 minus 12 minus 6 minus 3. So the part with a0 is obvious. That's 2 to the power of n. Those are the powers of 2. Now we need to figure out what this sum is. But observe that every term is twice the next one. So 24 is twice 12, 12 is twice 6, 6 is twice 3. So we can write this as 3 times, and then we're summing, well, if we factor out the 3, we have, starting from the right, 1, 2, 4, 8. So again, we're summing over the powers of 2, up to a factor of 3 in front. And again, we have a closed formula for this. This is 3 times 2n minus 1. Therefore, an is given by minus, because that's a0, 2 to the power of n, minus 3 times 2n minus 1. And after collecting the 2n, we get minus 4, 2 to the power of n, plus 3. Now we have the sequence starting at 2, where every term is n plus 1 times the previous term. So let's start with a1. That's twice a0. a2 is 3 times a1, which is 3 times 2, a0. a4 is 4 times a2, which therefore is 4 times 3 times 2 times a0. And we see the factorial appearing here. So the closed formula is, well, 2 because that's a0, and then n plus 1 factorial. Then we have the sequence starting at 3, where every term is 2n, the previous one. So A1 is given by 2 times 1, A0. A2 is 2 times 3, sorry, 2 times 2, A1, which is 2 times 2, times 2 times 1, A0. Let's do one more. A3 is 2 times 3, A2, which therefore is 2 times 3, that multiplies 2 times 2, that multiplies 2 times 1, A0. Now we have this factor of 2 that I've highlighted in red coming from the recurrence formula, the 2. And then we have these numbers in green, which come from the n in the formula. And so you see that there's a 1 in A1, there's a 2 in A, well, there's a 2 and a 1 in A2. In A3, there's a 3, a 2, and a 1. So we have a closed formula for an, which is 2 to the power of n, and that's for the red contribution, times n factorial, and that's for the green contribution, times A0, which in our case is 3. Finally, we have the sequence starting at 7, where every term is minus the previous one plus n minus 1. So let's write the first few terms. A1 is minus A0 plus, well, 0. Then A2 is minus A1 plus 1, which is A0 plus 1. Then A3 is minus A2 plus 2, which turns out to be minus A0 minus 1 plus 2. Let's do one more. A4 is minus A3 plus 3. And this is equal to A0 plus 1 minus 2 plus 3. So every time we get a new term, we have A0 that changes sign, and then we have this sum with alternating sign, and also the whole sum every time flip sign. So we can write this as, well, minus 1 to the power of n A0, which is just 7. And now we have the remaining sum. So that sum is the sum of the first positive integers with alternating sign, and also every new term we're switching the previous sign. So we also need to put a minus 1 to the power of n in front.